Okay. Yes. Done.
Yes, ma'am.
Yes, ma'am.
How you all have done this one?
Ma'am, with the formula of cos C plus cos D and sin C plus sin D.
Okay. So at first you have taken two cos C, cos D. So the first two you have taken together?
Yes.
No, ma'am, 4x and 2x, ma'am.
4x and 2x. Okay. Alvina, you have taken the first two, right?
No, ma'am. The last and the first.
Yeah, we'll be taking the last and the first one. Then only we will be able to proceed, because you can see here C plus D by 2 and C minus D by 2 will be the case. Whether it will be cos, cos, sin, sin, whatever. C plus D by 2 and C minus D by 2 will be there. So 4x plus 2x, that is 6x by 2. Ali, are you done? Are you there? Yes, Ali. If you have not done, then only I will explain. Are you done? Ali. Yes, Ali. Please respond. Okay, let's move. Meanwhile, if you will say, I will come to that. Now, the next one is cot x, cot 2x minus cot 2x, cot 3x minus cot 3x, cot x is equals to 1. Okay, let's try proving this one. What can be done over here?
Yes, ma'am. Ma'am, can we take cot common?
Yeah, we can take if that is working. Of course,
Cot,
that is the first thing which is
yes, ma'am.
coming in mind. Yeah,
Yes,
what can be taken out common?
cot into x plus 2x.
What you said?
Ma'am, we can
Cot.
take cot into x plus 2x minus cot into 2x plus 3x.
You are doing it like this, x plus 2x.
Yes, ma'am. Minus cot 2x plus 3x.
No, 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 not like this.
Okay, yes,
We
ma'am.
cannot take, we cannot take common like this. Okay, that's why I also I'm
Cot
thinking.
x plus y, that formula we can take.
Yeah, that formula we can take. See, whatever comes in mind, we are supposed to use that because who knows how to do it? And is there a single way? No, there are so many ways. Okay, so it looks like we can take cot 2x common over here from this two term. Common means from this two term cot 2x. Can you see?
Yes, ma'am.
Yes.
Maybe that is one of the possibility which is clicking at first, and the other possibility which is clicking is maybe from the other two term. From the other two term, maybe we can take common cot 3x. Okay, let's do both together and we will figure it out what can work. So at first in our mind it clicked that cot 2x, let's take common and we will be having cot x, okay, remaining minus cot 3x remaining over here, and the other term will remain as it is, cot 3x cot x. The other thing which came in our mind initially is cot x, cot 2x. Let's leave it as it is because with the other two term also there is a common, which is cot 3x. Okay, and the remaining is cot 2x and plus cot x, right? This much we realize, yes or no?
Yes.
Now, if we will try, now Albina said, can we use like the formula, for if so far we have not discussed cot 2x formula. Even if I will show you the formula, can you realize that cot 2x and this, like, it will just get so much of simplification and all. Even if we will use the formula, nothing will get cancelled out because 3x is here. For 3x also there is a formula, right?
Yes, ma'am.
Yes, ma'am.
Let's focus on the other way. Is it like something we can do for the other scenario? Just a second. Yeah. Over here, let's focus. So can we say that this one here we are having cot 2x plus x, cot 2x plus cot x we are having. See, this is a function, cot function is there, sine function is there. Okay, we cannot take just cot common over here. Okay, it's a combined with, along with the angle, it is combined form. Cotangent of 2x is given over here, and then cotangent of x is there. Now what is cotangent? Cotangent is the cotangents, the shorter form of cotangent is cot. Okay,
Yes, ma'am.
so this is not multiplication. If multiplication with x and y is there we can take out common, but here we cannot take out common cot. Okay, this
Yes,
cot
ma'am.
3x we can write it as a cot of 2x plus x. Yes or no? This one.
Yes, ma'am.
And we have learned the formula for this one, cot a plus b formula. Alvina, what was the formula for cot a plus b? Okay, we are not getting what was the formula for cot A plus B. But we know that cot is just the combination of cos and sine, right? Cot is just the combination of cos and sine, right?
Yes, ma'am.
Ma'am, it's cot A minus
Let's check it. Quick. Cos A,
cot
cos
A
B.
minus cot B minus 1 by cot
Yes.
B plus cot A.
Yes. Okay. From this part only we are going to get the formula. If we will divide numerator and denominator with sine A, sine B. Okay, if we will divide numerator and denominator with sine A, sine B. Here, sine A, sine B. Here, sine A, sine B. Because we want to create what? Here, sine A, sine B. And here, sine A, sine B. So the formula we'll be getting is cot A, cot B minus 1, yes or no, by cot B plus cot A. Getting it? That is the formula for cot A plus B. Is it clear?
Yes, ma'am.
Okay. We'll be using this formula cot A cot B minus 1 by cot B plus cot A. Cot A cot B minus 1 by cot B plus cot A. Right? Now can you see something is getting cancelled out? Can you see? Yes or no?
Yes, ma'am.
Getting it? Alvina and Ali?
Yes, ma'am.
It was cot, right? Yeah. It was cot, right? Or cos?
Cot.
Cot. The initial part we need to copy paste as it is. Okay. Now we can see over here that we are having, what are we having? Please tell me after doing the simplification what we will be having after this step. Please let me know.
Cot x, cot 2x minus cot 2x, cot x minus
Cot 2x, cot x. Minus 1 was there in the bracket, but when we will open the bracket, will it be plus 1?
Yes, ma'am.
Yes, ma'am.
And can we say we are done with having just 1?
Yes, ma'am.
Yes.
Okay, so this is how we will prove it. At first, it seemed like we can take out common factor. We have taken the first two, we have taken the next two. After taking the next two, we realized that we can cancel it, the bracket term. How? By just expanding this 3x as a 2x plus x and then using the formula. And we did so, and yeah, we are done. Any
Yes, ma'am.
confusion?
No, ma'am.
Let's continue. Now we have
Ma'am,
already discussed. Yes. More up, Alvina.
my name is Alina.
Sorry. In previous class, Alvina is there and I'm in that zone only. Yes, Alina, thank you so much for correcting me. I know your name is Alina, but now only in previous class, Alvina, so many times I said no. So that's there in my mind. Yes, sorry for that.
It's okay,
This
ma'am.
is This is what we are having. Okay, is it okay or shall I scroll up more?
Ma'am,
Ma'am,
this is
I'm done.
Okay, done. Let's continue. I don't like if someone don't call my name correctly, then I don't like that. And that is the problem actually. To you, I'm saying by mistake, I just said Alvina, Alvina. And to still, I'm not sure I'm calling your name properly or not. Uh, on first day, you told me it's not Siza, it's Shiza. So now, am
Yes,
I
ma'am.
saying it correctly? Yes or no?
Yes, ma'am, it's Shiza, ma'am.
Shiza, right?
Yes, ma'am.
Okay. Okay, I wanted to discuss the formula for tan 2x. We know tan 2x is just the combination of sine 2x over cos 2x, right? And for sine 2x, what was the formula? 2 sine x cos x, right?
yes.
Yes, ma'am.
And for cos 2x, the very first basic formula was cos square x minus sine square x. And from there, we have taken out so many new formulas, right?
Yes,
Now here,
ma'am.
if we will divide numerator and denominator with, we want to create tan x, okay? So we will be dividing numerator and denominator with sine, not sine, with cos square x. If we will be dividing numerator and denominator with cos square x, let's see what are we going to have. Cos square x, please tell me. Cos square x, what are we going to have?
Ma'am, in denominator it will be minus sine square x.
We are dividing with cos square x in the numerator and denominator. So numerator will be
Ma'am,
2 sin x.
numerator is it 2 tan square x cos x?
Let's cancel out. See, 2 sin x cos x we were still having, and we are dividing with cos square x. So
Yes,
one
ma'am.
cos gone. Can we say it is nothing but 2 tan x in the
Yes, ma'am.
numerator? Okay. And what about the denominator? Yes, Alina, you were saying.
Ma'am, tan square x. No, not tan
It is
square x.
1
Minus
minus
sine square.
in denominator cos square x minus sin square x is there. If you are dividing with cos square x, so cos square x by cos square x minus sin square x by cos square x. So 1 minus tan square x we are having, yes or no? Getting it?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. Let's continue. So this is one of the formula we generalize for tan 2x. Now the next question we will be doing that tan 4x is equals to 4 tan x in bracket 1 minus tan square x over 1 minus 6 tan square x plus tan to the power 4x. Let's try doing it. Tan 4x, it seems like we will be working on left side and we will use the formula and then we will be getting this much of part. Or maybe if meanwhile, if we will get
Excuse me,
stuck,
ma'am.
yeah,
Ma'am, once can you show the tan 2x above formula, ma'am?
yeah.
Okay, ma'am. Thank you, ma'am.
Yeah, let's continue. So we will be having here, if we will take the left hand side. Okay, the basic approach is Let's take the left hand side, try working on it. If meanwhile you are getting stuck, you are not getting where to go, leave it and just work on right hand side. Maybe from there it will be easier to reach to left hand side, right?
Yes, ma'am.
So let's try working on left hand side first, because now only we have seen the formula for tan 2x and it seems like we will be able to use the formula. So 2 into this 4x can be written as this one. So tan 2x, our x is this over here. Our x is this over here. Okay?
Yes, ma'am.
Let's use the formula. That formula was, what was the formula? 2 tan x. What
2
shall I
tan
write?
x by 1 minus tan square x.
2 tan x. At the place of x, what shall I
2
write?
tan 2x.
Over 1 minus tan square.
Tan square 2x.
That's correct.
Yeah.
Tan square
Now
2x.
still we can, yeah. Now still we can use the formula for this one and this one, right?
Yes, ma'am.
Okay, let's use it, because you don't have to plan that, oh yeah, this is how we'll be doing and then we'll be getting something, and that's how we will be getting the proof. No, planning doesn't work when we have to prove. Whatever is coming on your way, just keep on doing, you will end up proofing. Okay, so on our way, one more tan 2x came. We will be using the formula, that the formula for this is 2 tan x by 1 minus tan square x. In denominator, we will be using the same formula.
Tan square x.
Yeah, yeah, 4
Now
tan
it
square.
will be
Oh,
tan square 2x,
yeah,
right?
tan square 2x, where this one we are just writing the formula, Alina. Tan 2x formula is 2 tan x by 1 minus tan square x.
Okay, ma'am.
Getting it?
Yes.
Let's continue. One minus tan square 2x is there. So tan square 2x means what? Tan 2x, that's complete square, right?
Yes, ma'am.
Yes.
Right? Let's use the formula. 2 tan x by 1 minus tan square x. And that's complete square. Let's
Yes, ma'am.
continue. So this 2 is, we can multiply with the numerators too. Okay?
Yes,
So it
ma'am.
will be 4 tan x by 1 minus tan square x over 1 minus 2 tan x, that's square we will be doing. Can we write 4 tan square x?
Yes, ma'am.
Yes, ma'am.
And in denominator, 1 minus tan square x is there. That's a square we will be writing. 1 minus tan square x is fine. 1 minus tan square x is fine. That's a square we will be writing.
Yes, ma'am.
Okay. Let's continue. 4 tan x by 1 minus tan square x over 1 minus tan square x square is there. What will be the LCM over? What will be the LCM
1
if you want?
plus tan square x minus 2 tan square x.
Okay, you are expanding it. Yeah, that will be the LCM. So for now, let's write it compact form. Let's see the proof. So for now, let's write the compact form, Alina. Let's write it as it is, that LCM is this. Can we say LCM is this?
Yes, ma'am.
Okay. Now here 1 minus tan square x. That's complete square, right?
Yes, ma'am.
minus 4 tan square x, can we say as it is?
Yes, ma'am.
Any confusion, Alina, Ali, and
No, ma'am, no confusion.
Shiza, ma'am.
yeah, it's scissor, right?
Shiza, ma'am.
Wait, it's I'm coming to that. Okay, let's finish it first.
Yes.
So 4 tan x. Do you have any other name so that I can call you with that name? Scissor, right?
Yes, ma'am. Shiza, ma'am.
Yes,
It's
it's
all
such a
right, ma'am.
nice. Yes. Is there any other name which I can call you? Because I am having a habit of calling the name of the student again and again, again and again. So if by mistake also I'll end up doing mistake, so it will not feel good to you because I don't like it personally. Is there
Yes,
any
ma'am.
other name which you
Fatima,
want?
ma'am.
Okay, I'll be calling you Fatima. Okay.
Okay, ma'am.
Okay, because if anyone just spoil the name, no, it doesn't look good, like my name, or like even anyone from my family, if you are calling them and you are not calling them properly, it doesn't
Yes,
sounds
ma'am.
good. Okay, it's very
Yes, ma'am.
annoying. Let's continue. I'll be calling you Fatima.
Okay,
So
ma'am.
1 minus tan square x whole square is there. Really sorry if I have, like, I just if I have hurt you. My intention was not that.
No, ma'am. Not
I
at all,
was
ma'am.
not able. Seriously, I was not able to,
Not
like,
at all, ma'am.
it's the name. Your name is such a nice name you are having, but since like I'm not used to, that's why it's completely new to me. Okay,
Not at all a problem.
okay. So it is, this is what we are having. 1 minus tan square x whole square minus 4 tan square x is there. Let's
Can cancel it.
expand it now. So a square plus 2 minus 2ab minus 2ab plus b square, right?
Yes, ma'am.
Okay, minus 4 tan square x. Why we are expanding it over here? Why not we have expanded in the denominator part? Now only you will realize that, can you see that one of the tan square x and tan square x is getting cancelled out?
Yes.
This
Yes,
one
ma'am.
and this one. That's why
Yes,
at
ma'am.
first only we have not we have not expanded it. That we can cancel one of them and one will be remaining and one is reflecting in the proof part also. Okay, so yeah, let's continue. Here we can do the simplification. Can you see? Ali, Alina and Fatima. Can you see it? See carefully this one and this one.
Yes.
Yes, ma'am. We can take 2 tan square x common probably.
Minus 2 tan square x
Yes,
minus
ma'am.
4 tan square x is minus 2x minus 4x. If I will say that please do the simplification, minus 2x minus 4x, your answer will be
Minus 6x.
Minus 6.
minus 6x. So here can we say it will nothing but just minus 6 tan square x, can we?
Yes,
Yes.
ma'am.
Okay, let's continue. We are having over here 4 tan x over 1 minus tan square x, we are keeping as it is. And in the denominator, we are having 1 minus
Ma'am,
2
we
tan square.
cancelled it, right?
Yeah, if you want to cancel it over here, yes, let's cancel them. Or if you want to cancel it later, let's completely up to us. If you are comfortable, if you understand the concept, then yeah, we can cancel it over here. And if we will cancel
Yes,
it
ma'am.
over here, then we are left with this.
Only
If you
1 minus tan square x.
Yeah, 4 tan x will be there, and in the the extreme bottom, can you see 1 minus tan square is left? So can we
Yes,
take it
ma'am.
in the top?
Yes, ma'am.
Can we? Ali, Alina, and Fatima, are you getting it?
Yes,
Yes,
ma'am.
ma'am.
Okay, let's continue. So here we are having 1 minus 2 tan square x minus 4 tan square x, that is minus 6 tan square x. Okay, plus tan
Yes,
to the
ma'am.
power 4 x. This is what we are having in the proof. Let's check it. Yeah. Yeah, this is what we are having. We have written just in the denominator 1 plus tan to the power 4 at first we have written. Yeah. But that doesn't matter. Right?
Yes, ma'am.
Yes, ma'am.
So we are done with the proof, right? Are
Yes,
you
ma'am.
getting it, Ali? Ali, are you getting?
Yes, ma'am.
Only Alina and Fatima is responding. Where are you? Okay, you are also getting it. Let's continue.
Ma'am, please could you for a second show from the top of the.
Yeah, sure. This is the question.
Yes, ma'am.
This is what we are having.
Ma'am, I have a doubt.
Yes, ma'am.
Yes, Alina, please.
Ma'am, in today's test, the MCQ question, the value
Mm-hmm.
of tan 1 degree, tan 2 degree, tan 3 degree till tan
Mm-hmm.
89 degree is then in options it's 0, 1, 1 by 2 or not defined.
Okay, we'll be doing that. Okay. First note it down.
Yes, ma'am. Done.
Done completely?
Yes, ma'am.
No, ma'am. The next step.
Is it this one?
No, above. After that, conversion of 4x into. Yes, ma'am. After this next step, ma'am. This is done.
Is it okay?
Yes, ma'am. Done, ma'am. Yes, ma'am. Yes, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah, let's continue. Yes, Alina, the question was tan 1, tan.
Tan 2 degree, tan 3 degree until tan 89 degree.
Okay, we are supposed to calculate the value of this one. Let's do it. Tan 1 degree. Now tan 89 degrees there. Can we write this tan 89 as a tan 90 minus 1? Can we?
Yes,
190 minus 1. Tan 90 minus theta is what? Pi by 2 minus theta we have seen. Tan pi by 2 minus theta. With pi by 2 the angle changes. It's like this. In radian we have learned everything.
Yes, ma'am.
With pi by 2 this trigonometric function will change. So tan will change to cot theta. Now the question is whether it will be plus or minus. So with pi by 2 minus theta lies in which quadrant? First, second, third or fourth? Yes, anyone? Ali, Alina and Fatima. Anyone?
Ma'am, is it first quadrant?
Yes, it is first quadrant. In first quadrant, all are positive, right?
Yes, ma'am.
Yes, ma'am.
So it will be just cot 1. Yes or no?
Yes, ma'am.
Yes,
So we
ma'am.
can write tan 89 as a cot 1. We can, here tan 88 must be there, right? Here tan, if dot 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 is there, that means it is there, like tan 87 must be there.
Yes,
Then
ma'am.
tan
Yes, ma'am.
86 must be there. All must be there. So let's see for few. This 88, we can write it as a tan 90 minus 2. Yes or no?
Yes,
Yes,
ma'am.
That means cot 2 degree. This one can be written as cot 3 degree.
yes, ma'am.
Yes,
This
ma'am.
one can be written as cot 4 degree. Now, now the question is, all will get cancelled out. All will get cancelled out. That is the main thing. So just a second. What was the option, Alina?
0, 1, 1/2, or not defined.
See, one from 1 to 89, this much terms are there, right?
Yes,
Okay,
Yes, ma'am.
right. That means total 89 terms are there, right?
Yes, ma'am.
yes,
Okay, that means the first half, last half will cancel each other, of course, right?
Yes, ma'am.
Are you getting it? 89 terms are there. So here 44, here 44, here 45th term. Yes or no?
Yes,
44
ma'am.
plus 44, 44 plus 44, 88.
88.
And then this is not 40, it is just 45th term. AP you have learned, right?
Yes, ma'am.
Okay, so this is 45th term, the like one of the term which is in between. So I think this one and this one all together are getting cancelled out, and we are just left with tan 45 degree. Yes or no?
yes, ma'am.
Yes, ma'am.
That is just one. So the result will be one, right? Getting it,
Yes,
Alina?
Yes, ma'am.
Okay, so this is how we are supposed to solve it. Okay, by understanding the concept that, yeah, one will be the answer.
Excuse me, ma'am.
Yeah.
Ma'am, will it get cancelled by with the help of the conversion, ma'am? Like if we convert tan 88 into cot 2 and cot 2 tan 2 will be get cancelled?
Yeah.
Yes, ma'am.
This tan 1 and this cot 1, the last one, will get cancelled because tan 1 into cot 1 is just 1. Okay.
Yes, ma'am.
Similarly, tan 2 into cot 2 is just 1. Why 1? Because we know cot is the reciprocal of tan. Tan
Yes,
x
ma'am.
into cot x is 1. Why? Because cot is just the reciprocal of tan. It means 1 by tan.
Yes, ma'am.
That's why we are
So
saying
tan
that it
tan
will
cancel and 1.
1 will be there. Okay,
Yes,
this
ma'am.
is how we are making the pair. But we have successfully made 44 pair and one is remaining. So we realize that the remaining one is 45th one. Tan 45 degree will be the remaining, and that value, yeah, we know accurately it's 1.
Yes,
Okay.
ma'am.
So the remaining product were 1 and this is also 1, hence the final result is 1.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay. Let's continue.
Ma'am, I have another doubt.
Yeah, please tell me,
If x
Alina.
is equal to r sine theta cos empty set comma y is equal to r sin theta sin.
Have I written correctly? X is just r cos theta.
No, ma'am, it's not correct. X
Okay,
is
tell
equal
me.
to r sin theta.
Okay.
Sin
Then,
theta into cos empty set. That symbol is there.
oh, phi. It's angle phi.
Yes, ma'am. Fine.
Phi. Okay, Alina, we will be calling, yes, it's empty set we represent with this symbol, but we also represent angle just like theta. This is also an angle. It's called phi. Okay, phi phi. It's from Greek alphabet we have taken this one. So yes,
Phi comma y is equal to r sin theta into sin phi,
then
and z is equal to r cos theta. Then x square plus y square plus z square is independent of.
let's check it. X
Ma'am, the
is
options are theta comma phi, r comma theta, r comma phi, and only r.
okay. Let's try doing it. We are coming to the option part. Y is r sine theta sine phi. Okay, this is square is there. R sine theta sine phi. This is square is there, and z is r cos theta. This is square is there. Okay, let's try solving it. We will be having r square sine square theta cos square phi plus r square. See, something I can see is getting we can take out as a common factor. You can also see yes or no
Yes, ma'am.
from the first two terms. Can you
R
see
square
what?
sine square theta
Yes, r square sine square theta. And what are we left with?
into cos square phi plus sine square phi.
Yes. This is nothing but it's cos this phi is just like an angle. Okay, and alpha we use for representing the angle, theta we use. So this is also angle. Phi is an angle. So this is one, yes or no?
Yes, ma'am.
And here r square sine square theta. Again, I can see something is we can take out as a common factor.
And r
R square.
square
Yes, perfect. Sine
Again,
square
we'll
theta.
get 1, ma'am.
plus cos square theta,
Yeah,
which is 1.
yes, which is 1. So r square is left. I can see
Yes,
in
ma'am.
our answer, after doing this much of simplification, we are not having any theta and phi.
Yes, ma'am.
So we can say it is independent of theta and phi.
Yes, ma'am.
If option is there independent of r also, so that we cannot say. R is there. It is just independent of theta and phi because
Okay.
that is not reflecting in the answer part.
Yes, ma'am. Ma'am, next can you show up the question, ma'am?
Show the answer.
This was the question. X, Y, Z is given over here, and it was we were supposed to calculate x square plus y square plus z square.
Yes, ma'am.
Ma'am, can you move towards the right side a little?
Yeah, sure.
Done, ma'am.
Done. Done. Can we proceed?
Yes, ma'am.
Yes, ma'am.
And any more question is there, Alina?
Yes, ma'am. Which of the
Yeah.
following is incorrect? Then option A, sin x is equal to minus 1 by 5. Option B, cos x is equal to 1. Option C, sec x is equal to 1 by 2. Option D, tan x is equal to 20.
Wait. Sin x is equals to minus 1 by 5. Cos x is equals to 1. Option number 3 is
Sec x is equal to 1 by 2.
and option number 4 is
Tan x is equal to 20.
let's check it. We are having an idea about domain and range. Have we discussed?
Yes, ma'am.
Have we? Okay. So we know the output for sine function lie in between minus 1 to 1 ranges. Yes or no?
Yes, ma'am.
Minus 1 by 5 means minus minus 0.2. Is it lying in between minus 1 to 1? Is it?
Yes, ma'am.
So this is okay. Next one. We know the output for this one also is minus 1 to 1, and here 1 is there and close interval we are having. So yeah, that is fine. Okay. Next one, sec function. We already know the output for sec function is like sec means 1 by cos, and cos output for cos will be lying in between minus 1 to 1. Hence we realized that if we are taking any number in between minus 1 to 1, the result is coming like beyond 1 and just beyond minus 1. So for sec function, the output was coming over here and over here, right?
Yes, ma'am.
Yes,
Okay,
ma'am.
that means all real number minus minus 1 to 1. This is how we were writing the range for sec function. Now 1 by 2, can you say, just a second, can you see this 1 by 2 is lying over here in this particular range?
Yes, ma'am.
So is it possible even?
No, ma'am.
No. Okay, it is not at all possible. Now let's check the last option also. Tan x is 20. Tan x is 20. Okay. And we have already discussed that tan is the combination of sine and cos. And we have also discussed what will be the possible output for tan, right? Domain and range. Who will say? Ali, Alina, and Fatima. What is the domain and what is the range for tan function? Domain means input. We can take any real
We
number.
can take, yes.
Ma'am,
Any
for
real
tan,
number.
range is R.
Ranges are okay. So 20 we are having over here, and that is fine. Any real number can be the output. Output is 20 is fine. So the third option is the incorrect one. Getting it? Getting it?
Yes, ma'am.
Ma'am.
Okay. So this is how we have to check this type of question. That whatever is given, is it valid or invalid? Like for lower classes, you have seen this type. Like if all of a sudden I will write that 5 is bigger than 8, it is completely illogical, right?
Yes, ma'am.
Yes, ma'am.
Similarly, the third one is completely illogical. Okay. Yes,
Yes.
Alina, more questions? because almost we are done with this chapter.
Ma'am, can you go a little up, ma'am?
Yeah, sure.
No, ma'am, this part is done, the second part.
This.
Yes, ma'am. Yes, ma'am, thank you,
Yeah.
ma'am. Done.
Yeah. Yes. Any more question, Alina?
No, ma'am.
Okay. So yeah, here
Excuse me, ma'am.
yes,
Ma'am, if you
Fatima.
don't mind, actually I was not I'm not aware of the domain and functions of the trigonometric functions. So if you don't
Yeah.
mind, can you write it in the order, ma'am?
Yeah, sure. I will write it and I will explain also to you, because the next few question over here, you will be able to do that just by using the formulas and all. So let me explain a little bit.
Yes, ma'am.
Trigonometric function, we are having sine function, we are having cosine function, we are having we are having tan function, we are having cotangent, we are having sec function, and we are having cosec function. Okay. For sine function, we realize that the graph of sine looks like the sinusoidal curve is there. That means this type of curve is there for sine function. Here also same way. Okay. So we realize that any x value we can take for sine function. The input x can be any real number, right?
Yes, ma'am.
Okay, that's why we say that domain means the input x and range means the output y. That's why we say that domain is all real number. Now range, what is the range? So if you will look at the sine functions graph, you will find that it is just moving like this, like this, like this, like this, like this, and maximum up it is going till 1, and minimum down it is going till -1, and beyond that it is not even moving. Okay.
Yes, ma'am.
That's why we say the output will always lie in this range. Okay, similarly
Yes,
for
ma'am.
cos functions graph is also like sine function, not exactly same to same, but just like sine function. So that's why here also the input is any real number, but the output is -1 to 1.
Yes, ma'am.
Okay, now tan function. Tan is just the combination of sine over cos. So the domain of sine is all real number, domain of cos is all real number. So can we say domain of tan is all real number? This is R I'm trying to write, okay? In bold, we
Yes,
do
ma'am.
write like this. So can we say that the domain of tan is all real number? Yeah, we could have said, but we know that in mathematics, 0 in the denominator is not acceptable, right? Right?
Yes, ma'am.
If I will say 2 by 0, it is not defined. X by 0, it is not defined. Okay.
Yes,
So
ma'am.
0 in the denominator is not defined. That's why wherever this cos, the denominator is 0. Separately, wherever cos is 0, that is making sense. That yeah, the result is 0. But if it is sitting in the denominator and then it is creating 0, then we will say that don't give the output as a 0. Apart from that, you can give any output, but don't give 0. So cos will say that, okay, I give 0 at odd multiple of pi by 2. I will show you the graph also, at odd multiple of pi by 2, it always creates 0. Okay, this is the sine graph I have plotted. Okay, so odd multiple of pi by 2, that means at pi by
Yes,
2,
ma'am.
at 3 pi by 2, at 5 pi by 2, at 7 pi by 2, at 9 pi by 2. These are the odd multiple. Similarly, minus pi by 2. Similarly, minus 3 pi by 2. So, at odd multiple of pi by 2, it will give you the output 0, the cosine function. Okay,
Yes,
that's why
ma'am.
we need to exclude those points, and we will write it as a 2n plus 1 pi by 2. 2n plus 1 means you take n as any integer, 0, 1, 2, 3, 4, anything you
Yes.
start taking, and you will start getting odd multiple of pi by 2. That is the domain. Why? Because
Yes,
we
ma'am.
are excluding all those points which are creating confusion. Okay.
Yes, ma'am.
Now the range. What is the output? What is the output? So if we are taking input as any real number, tan function, the output, like if you will see the graph of the tan function, the graph goes like this. It just go till infinity on the above, until negative infinity in the like below. Let me
Yes, ma'am.
show you the proper way. I will be showing you the graph. Okay,
So
so
maybe we
that's
can
why
take it as all real numbers, ma'am?
yes, we can take it as all real. Similarly, here for chord also all real number, and here for chord domain is also all real number minus the problematic point. Chord means cos by sine. So wherever the denominator is 0, that is not acceptable for chord. For sine
Yes, ma'am.
function, it is okay. That result is 0. 0 is okay. Answer can be 0, right?
Yes, ma'am.
But for chord, it is not acceptable because their sign is sitting in the denominator. So that's why we know that for, yes, Alina, you will say, what is the domain for chord function? Yes, Alina. Ali,
Ma'am, I
Ali,
remember range only.
range only. Where exactly sign is 0?
Sine is
Where
0
exactly?
and 90. No, not
Okay.
90. 0, 0. 0 degree.
0. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, integral multiple of pi. Is it so? Integral multiple of pi, that is n pi.
Yes, ma'am.
Okay. Sine is 0. At pi also sine is 0. Okay. At pi also sine is 0. Sine pi value is 0. If you want to check, you can check it. You can write pi means 180 degree. You can write it as a pi by 2 plus pi by 2. Yes or no?
Yes, ma'am.
And pi by 2 plus theta, transformation will occur.
In
It will
second
change to
quadrant, ma'am.
cos. In
Yes, ma'am.
second quadrant, result will be positive. Cos pi by 2 is 0. Can you see sine 180 degree value is 0?
Yes, ma'am.
Okay. That's why we are saying that everything, all real number is okay, but not this n pi. N pi means any integral multiple of pi. Okay, 0. If you are taking n as a 0, so 0. N as a 1, so 1 pi. N as a 2, 2 pi. N as a 3, 3 pi. N as a minus 1 pi. So like that, integral multiple of pi. These are the point which we need to exclude, because at this point the function will not be defined. Now the sec function. Sec function is also 1 by cos, right? So
Yes,
can we
ma'am.
take the domain of cos? Yes, we can take that domain of cos. But wherever cos is 0, that we will exclude, right? Because it is sitting in the denominator over here.
Yes, ma'am.
So can we take same like tan? Yeah, because there also cos was there in the denominator, right?
Yes, ma'am.
So yes, we'll be taking same like tan. And this one will be taking same like cot. Domain. And range, what about the range of sec and cosec function? So range of sec function, now only we realize, Fatima, let me explain you that when you will be taking any number in between -1 to 1, you can check it in your calculator. If you will be taking 1 by 0.5, you will be getting a number which is not lying in between -1 to 1, which is lying
Yes,
in
ma'am.
this range and in this range. you will be taking 1 by any number which is in between these values. Any number you will be getting, but always you will be getting the output in this purple zone. You
Yes,
take
ma'am.
minus 0.009, you take it, you will be getting a huge negative number. So that's why in between this range, like in from this area, particular area, whatever number you will be taking, your output will be in this purple range. Okay, that's why we say that the range for sec and cosec function is all real number minus negative 1 to 1. That means the negative 1 can come.
Yes,
Sec
ma'am.
means 1 by cos. Output for cos is lying in between minus 1 to 1. If we will be taking minus 1, the sec will also generate minus 1 as a result. Yes or no?
Yes, ma'am.
If we will be taking plus 1, sec will also generate plus 1 as a result. If we
Yes,
will be
ma'am.
taking any number in between, then sec will generate result in this purple zone. That's why we are saying that minus 1 can come, 1 can come, but anything in between will never ever come.
Yes,
Okay.
ma'am.
And we also write it like this, that from negative infinity to negative 1 close. From 1 to infinity, like this. This is the range of sec and cosec function. And the same thing we write it as a all real number minus negative 1 to 1. You check it, Fatima, that we are excluding all number in between minus 1 to 1. We are not excluding minus 1 and 1. Can you
Yes,
see?
ma'am.
So that's why we write it as a all real number minus
Yes,
minus 1. All real number minus minus 1 to 1. Both are same because for sine and cos, the output is lying in between minus 1 to 1. Getting it?
yes, ma'am.
Yes, ma'am.
Okay. And let
Yes,
me
ma'am.
check what else are we done with everything or we are left having anything? See, next cos 4x is there. After that cos 6x is there. We will be doing cos 6x1. We will try it. And yeah, I will be sending you the portion of one page, one sheet I'll be sending you where all the formulas will be there, which you need to learn. Okay.
Yes, ma'am.
And
Thank you,
yeah,
ma'am.
before doing this one, let me tell you there exists a formula for tan 3x also, sine 3x also, cos 3x also. And basically this formula, sine 3x formula, we will be getting this formula from sine of 2x plus x. Okay, let's try finding this formula, then we are coming to that part. Sine 2x plus x, which will be sine a cos b plus cos a sine b, right?
Yes, ma'am.
Which can be written as sine 2x means 2 sine x cos x. Yes or no? Ali, Alina and Fatima. This one
Yes,
will be
ma'am.
cos x plus cos 2x.
Cos square x minus sin square x, ma'am.
Yeah, but can we use the other formula which is in terms of sine? 1 minus 2 sine
1
square x
minus
was there?
2 sin square. Yes, ma'am.
Yeah,
Yes, ma'am.
let's continue. So from here we are getting 2 sine x is there, fine. But cos square x is there. And here we are having sine x minus 2 sine cube x, right?
Yes, ma'am.
Right? Now from
Yes,
the
ma'am.
first two term, can you see something we can take out as a common factor?
Sin x.
Sin x, ma'am.
Yes. Let's continue. Now can we do anything over here? 2 cos square x plus 1. If we will try writing it in terms of sign, what are we going to get?
Sine square
First
x,
step
2
of
sine square x.
this one is a 1 minus sine square x, because we want to keep everything sine, sine, sine. We are trying to find sine 3x formula. Okay. So sine x we are copy
Yes.
pasting. Curly bracket I am giving. 2 I am giving over here. Plus 1 I am giving over here. Curly bracket close. Minus 2 sine cube x.
Yes.
Any confusion?
No, ma'am.
Okay. Then I am doing over here. That it will be sine x is okay. In curly bracket 2 minus 2 sine square x plus 1 minus 2 sine cube x. Getting it?
Yes.
Then we'll be getting, let's open the bracket. Okay, 2 plus 1 is 3. So let's make it 3 minus 2 sine square x. Any confusion so far?
No,
Ali,
ma'am.
Alina, and Fatima.
No.
3 sine x minus 2 sine cube x minus 2 sine cube x. Can we say this two combined together will be what?
Yes, ma'am.
Sine cube x.
Minus 4 sine cube x.
This is the formula. Sine 3x formula is 3 sine x minus 4 sine cube x. Okay, from here we got. So basically the process is not helping us that much, right? You can see the process is not going to help us that much. This much long process will, are we going to do anytime? No.
No, ma'am.
Better we learn the formula, right? Yes, for C and D, the process was helping us, right?
Yes, ma'am.
Okay, the process was helping us to keep in mind that cos C plus cos D, either we will be having cos cos or we will be having sin sin. But when C plus D is there, we are getting cos cos, right?
Yes.
Yes, ma'am.
So that time process, genuinely it helped us a lot. But these formula anyway you have to learn it. That's why I'm not going in detail with the proof and all. I will be sending you all the formula in one place. Just keep it properly and try solving. Practice the question at first,
Now what
and
about cos 3x?
cos 3x will be just like this one, just the reverse way of this one. Uh, just a second. It is 4 cos x minus 3 sine 3 cos cube x. Let me confirm once. Just a second. Yeah, it is just the reverse way of this one. That is 4 cos. It is this part is at first 4 cos cube x minus 3 cos x. Yeah. Can you see the when you will learn the sine one, you will be able to write the cos one.
Yes, ma'am.
Yes.
Okay. So these are the formula, and let's
Ma'am,
finish this. Yes.
ma'am, will you be sending all the formulas as a list on the web portal, ma'am?
Yeah. What you said, Fatima?
All the formulas together, will you be sending them on the web portal or on WhatsApp, ma'am?
I will be sending it to you.
You said it, ma'am. You'll be sending the list of formulas together.
together I will send it to you through your WhatsApp. Okay.
Okay, ma'am.
In your WhatsApp number, I will ask my operation team to forward it to you all.
Okay, ma'am. Thank you,
Okay.
ma'am.
Okay, ma'am.
Yeah, because it's that important. Okay, in class 12, again and again, this trigonometric formula will keep on coming, and you have to keep it in one place. Of course, you have to memorize all the formula, and you also have to keep it in one place. So this is what we are having: minus 48 cos to the power 4x plus 18 cos square x minus 1. This is the last question. Okay, in between, if you solve any question and you will get stuck, you are going to let me know. We'll be taking it in class. So let's take the left hand side. It looks like we will be able to do it. We can write it as a cos 2 into 3x or 3 into
Yes,
2x.
ma'am.
Anything we can write, right?
Yes, ma'am.
Just now we learned the formula. Let's write it 2 or maybe 3 into 2x. What you want to take? Which one? Vote for it. Which one you want to take? Because I think
2 into
anything will
3x,
work.
ma'am.
2x.
Okay, 2x. Okay, anything will work over here. Let's take any one of them. Okay, if you want to take this
Yes,
one,
ma'am.
because this for here we are having so many formulas. So now the question will be which formula to use. Here cos 3x, just one formula you have seen, that was this one. This one, 4 cos cube x minus 3 cos x. So here there is no chance that we will start thinking which formula to use and all. We are having cos 3x, one formula, we will be using that. That is 4 cos cube x minus 3 cos x, right?
Yes, ma'am.
Yes, ma'am.
Okay. Now let's see what is there in the proof. Cos to the power 6 and all is there. Okay. So this one, and all cos are there, sine is also there. No, all cos are there. So let's write it as a 4 cos 2x complete cube we are having. Let's write it in the cos formula. What is the cos formula we are having? Not the sine one, just the cos one. Cos 2x formula in terms of cos only. Was it 2 cos square x minus 1?
Yes, ma'am.
Okay, and this one also I'm going to take the cos formula, because in the proof part all cos we can see, right?
Yes, ma'am.
If you are using the other approach, try sticking with the cos only formula. So cos 2x is 2 cos square x minus 1. Let's continue. 6 cos square x plus 3, right?
Yes, ma'am.
Now this is a minus b whole cube. Formula is a cube minus 3 into a into b in bracket a minus b minus b cube. Are you able to recall the formula? A cube minus
Yes,
3ab
ma'am.
in bracket a minus b cube. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, I think we need to write it properly. Just copy it this much.
Done, ma'am.
Done, ma'am.
Okay. So now we will be having 4. 2 cos square x whole cube will be 8 cos to the power 6x, right?
Yes, ma'am.
See, a to the power n is a to the power m into n.
Yes,
So
ma'am.
we need to multiply the powers. Minus 3 2 times 6 cos square x we are having over here. If you will multiply 6 cos square x with 2 cos square x, it will be 6 2 times 12. Cos square
12.
x into cos square x is cos to the power
4.
4x. Now 6 cos square x minus 1, that means plus 6 cos square x. Is it so?
Yes, ma'am.
Now minus 1 cube is just minus 1. Minus 6 cos square x plus 3.
Yes, ma'am.
Yes, ma'am.
Let's open the bracket. 8 4 times
Ma'am, we have 6 cos square x common.
common. Or let's open the bracket because there is 4 outside, which is just with this curly bracket. Right, Alina? Right?
Yes, ma'am.
That's why I'm opening the bracket at first. 6 4 times 24 cos square x minus 4 minus 6 cos square x plus 3. Now this one and this one is a like term. This 4 and 3, this 2 can be combined together. Let's
Yes, ma'am.
continue. 32 cos to the power 6x minus 48 cos to the power 4x. 24 minus 6 is 18. Is it 18?
Yes, ma'am.
Yes,
Yeah,
ma'am.
we are done. We are done. Can you see? It's not that difficult. Just
Yes, ma'am.
formula based. All the proof are just formula based. Okay.
Yes, ma'am.
Ma'am.
So we are done with this complete chapter. And yeah, today we will be deciding which chapter is the next chapter. Yes,
Yes, ma'am.
Fatima, you told me that quadratic equation and